2016 additional mathematics paper. And again, we know this paper has 4 sections. Section 1, Section 2, and Section 3, you do everything. Section 4, you only choose 1 out of 2 questions. And Section 4, you know, you have statistics and probability. So let's, statistics and probability and kinematics. So let's get into it. The formula sheet, and here we go. It says the domain of the function f of x, which is 2x minus 1, is minus 2, minus 1, 0, and 1. And it says determine the range of the function. The range are just the corresponding y values, all right? So we need to find the lowest y value that will satisfy this function for this particular domain and the highest y value. So generally, the range is going to be between f of the lowest x value in the domain and less than or equal to f of the highest x value in the domain. All right, how do I know that? Because this is a linear function. All right, so the range is just going to be y is going to be between, so y is less than or equal to f of 1 and y is greater than or equal to f of negative 2. Again, I know this because a straight line is linear. All right, as I said, straight line and linear, same thing. F of x is equal to 2x minus 5 from negative 2 to 1 looks something like this. All right, let's say that's when it's negative 2, this is when it's 1. So the lowest y value is going to be right here, which is f of negative 2, and the highest y value is going to be 1. And we know it cuts the y-axis at negative 5. So that's the range. So the range is just y is between, what is f of negative 2? F of negative 2, you put negative 2 here. Negative 2 times 2 is 2 times negative 2 minus 5. That's minus 9. So y is between minus 9 and you put in when x is 1, 2 times 1. 2 times 1 minus 5. I'm getting minus 3, so it actually don't even reach up here so yet. So that's the range. The range is between minus 3 and minus 9. Now it asks us to find the inverse of this function. All right, now to find the inverse, we have to interchange x and y. And so what we're saying is x is equal to 2y minus 5. So we make y the subject by adding 5 to both sides. So we'll get x plus 5 divided by 2. That's y. If this is y, then this is f inverse of x. So this is going to be f inverse of x. Nice and easy. Now it says, sketch the graphs of f of x and f inverse on the same axis. It says sketch, so you don't need to kill out yourself. All right, you don't have to. It's a sketch. So I'm going to get out my y and my x-axis. All right, and first I'll sketch f of x. Now the domain was, you have to remember the domain. The domain was between negative 2 and 1. Negative 2 and 1, all right? So the corresponding y values were f of negative 2 was negative 9. All right, I know f of negative 1 is going to be negative 7. Cuts the y-axis at negative 5. So this is negative 5. And then f of 1 is negative 3. Maybe negative 3 somewhere here. So this straight line represents f of x. All right, that's f of x. Now we want f inverse of x. F inverse of x, look back at it. F inverse of x is x plus 5 over 2. So it cuts the y-axis at 5 over 2. All right, and it have a positive gradient of a half. All right, so let's sketch this now. F inverse, x plus 5 over 2 cuts the y-axis at 5 over 2 and a gradient of a half. All right, gradient of a half. Gradient of a half cuts the y-axis at 5 over 2. 5 over 2 is 2.5. All right. Something like that. All right, I don't like how this look like the gradient is bigger than this gradient, which shouldn't be because the function has a gradient of 2. So let me make this a little more better. I want to show that the gradient is a half. So it shouldn't be steeper than this one. So maybe that's better. They intersect somewhere down here, all right? They ask comment on the relationship. So let me just put 5 over 2 here. And label them that this is F inverse and this is F. Comment on the two. They're a reflection of each other in the line y equal x. All right? They are a reflection of each other in the line y equal to x. All right, so that's it. They're a reflection of each other in the line y equal to x. Now it's saying now to solve the equation 2 to the 2x plus 1 plus 5 times 2 to the x minus 3 equals 0. So to solve this equation, what you are going to do is, first thing, this 2 to the 2x plus 1, you can separate it as 2 to the 2x times 2 to the 1, right? By laws of indices, we can break it out like that. Plus here 5 times 2 to the x minus a 3. Nice. Now this look like we can solve this now, right? Then now this 2 to the 2x by laws of indices. All right, I don't like these whole heap of lines. I prefer when they give me the space. Now this 2 to the 2x can be written as 2 to the x all square. 2 to the 2x is the same as 2 to the x all square. All right, but then it's being multiplied by 2, so I can just put a 2 on the outside here, plus 5 times 2 to the x minus 3 is equal to 0. Now you may realize that this is like a hidden quadratic. If you call 2 to the xy, this is like you have 2y squared plus 5y minus 3. So call it y, call 2 to the xy, so you have 2y squared plus 5y minus 3, and that equals 0. Clearly. So now that you have a hidden quadratic, you can stay so now and factorize, and you equate it to 0. Now 2y squared can be broken up as 2y multiplied by y, and minus 3 now, it's going to be 3 and 1. Signs are different, and the bigger number goes with the plus, so you put a plus here and a minus here. Let's check if we factorize it right. This time this is that. This time this is 6y minus y, which is plus 5y, so this is correct. So what are we saying then from this? We're getting that y is equal to a half. And from over here, we're getting y equal negative 3. If you're getting y equal to a half, remember y is 2 to the x. So what we're saying is 2 to the x is equal to a half. 2 to the x equal to a half, and from here, so we're saying 2 to the x is negative 3. Now 2 to the x can't equal to negative 3. So what you're gonna write? You're gonna write right here. That's crazy. That's crazy. So you can just put that. That's crazy. Don't be afraid to express yourself. That's crazy. You can't raise a number to a power and get a negative result. All right, so let's write 2 to the x is a half. Say 2 to the x is a half. We can say, all right, if 2 to the x is a half, then 2 to the x is actually equal to a half right now. You can write a half as, we can rewrite a half as 2 to the minus 1. All right, don't it? We can always rewrite a half as 2 to the minus 1. So what is x? X is negative 1. X equal negative 1. Nice and easy. When you finish, you can always check your solution. Plug in x equal negative 1. You're going to get 2 times negative 1 is negative 2. Negative 2 plus 1. Negative 2 plus 1 is negative 1. And so you get 2 to the negative 1 plus 5 times 2 to the negative 1 minus 3. 2 to the negative 1 is a half plus 5 times 2 to the negative 1, which is a half plus 5 over 2, which is 3, and 3 minus 3 is 0. So yes, this is right. Nice and easy. So good. Soft. All right, now this says given that t is equal to k times p to the, that looks like h over c, make c the subject. I'm going to say this again. Anytime the unknown is in the power, you take logs of both sides. Anytime the unknown is in the power, the first thing you do is take the logarithm of both sides. So what we're saying then is the log of t. Now a lot of people like to write log. All right, I write LG, it doesn't matter. All right, LG, LOG, doesn't matter. All right, so the log of t is equal to the log of k times p to the h over c. Now we can separate this side now by saying log a b is the log of a plus the log of b. So we can rewrite this now as the log of k minus the log of p raised to the h over c. Yeah, we can definitely do that. And this is the log of t. All right. Now, by laws of logarithm, we can bring down the hc. So I can't bother to write it in another step. So I'm just gonna write in here, bring down the power h over c. By laws of logarithm, we can do that. So now let's go ahead now. We can bring over log k over here to get log t minus log k, which is the log of t over k. So the log of t over k is going to be equal to minus h over c times the log of p. And we want to make c the subject, right? So no issues. To make c the subject from here, depends on which way you want to do it first. First thing I will do is I will multiply both sides by 1 over h. I'll multiply both sides by minus 1 over h, sorry. If I multiply both sides by minus 1 over h, I'm going to get minus 1 over h times the log of t over k is equal to the log of p times 1 over c. All right, nice and easy. So now to make C the subject, you just can do it in 2 steps now. So you divide both sides by log P, and then you flip it. All right, you can just flip it. All right, or what some people just say is cross multiply. You bring the C up here and bring all of this down there. So in general, conclude, you can flip it by saying, bring the C over here and then divide everything into down here. And so what it works out to be is, let me separate it in black. C is actually equal to the log of P divided by all of this right here. Now you can actually bring up the power, you know. You can write it as log of P divided by the log of T over K to the minus 1 over H. That's how you find C. All right, nice and easy, soft. Now let's look at this part of the question now. Now they say the log of x plus 1 plus the log of x minus 1 is equal to 2 log x plus 2. And find what is x. That's what they mean when they say solve the equation. To solve this equation, you need to make x the subject or find x. So we can connect them by saying log a plus log b is the log of ab. So this works out to be the log of x plus 1 times x minus 1. And that is going to be equal to, we can bring up the power and write it as the log of x plus 2 all square. Yes, you can bring up the power. Write it as x plus 2 all square. Now, if log a is equal to log b, then a must equal b. So what that means then is x plus 1 times x minus 1 is equal to x plus 2 all square. So what they're saying is x plus 1 times x minus 1 is equal to x plus 2 all square. Nice and easy. Now, after you get to this stage now, what you need to do is you need to solve for x. So we can expand out the bracket now. X times x will give us x squared. But this is just a difference of 2 squares. So it's really just x squared minus 1 is equal to expand out x plus 2 all square. That's going to give us first term square plus twice the product of the 2, which is 4x, plus second term square. So we're solving x squared minus 1 is equal to x squared plus 4x plus 4. Now bring over x squared over here. X squared going to cancel with the x squared. All right. All right, let's bring it over to this side. I'm going to bring over everything to this side. X squared over here. X squared is going to cancel. Bring over the minus 1. And so I get 0 is equal to 4x plus 5. And if 0 is equal to 4x plus 5, then x is going to be equal to negative 5 over 4. And that's the solution. X is negative 5 over 4. Nice and easy, soft, with a capital T. And you can always check back your answer. You can put x as minus 5 over 4. All right, and just see if it satisfies that equation. All right, nice and easy. Now this question, part 2. Question 2 now is dealing with discriminants. It says determine the nature of the roots of the quadratic equation. To determine the nature of the roots, the first thing you find is b squared minus 4ac. So b squared is 3 squared minus 4 times 2 times minus 9. So b squared minus 4ac, that is equal to, when you work out the discriminant, Let's check it out. 3 squared minus 4 times 2 times minus 9. B squared minus 4 AC. I get 81. So what does that mean? If we get B squared minus 4AC is equal to 81, which is greater than 0, then what that means is that the roots are real and distinct. All right? So we can say the roots, this is describing them now, describing their nature. The roots are real and different. That's what that means. It then goes further now and to say, given that f of x is this, sketch the graph of the quadratic function indicating the minimum value. Now, before I sketch the graph, I want to find the minimum value. The minimum value, yt, the minimum value is yt, or some people like to call it k. Some people like to call it k. The minimum value is 4ac minus b squared over 4a. This is the minimum value, all right? That's how you find the minimum value. So finding the minimum value is actually 4 times minus 9. That's c times a, which is 2, minus b squared, which is minus 9, over 4 times a, which is 8. Let's work out that now. So we have 4 times minus 9 times 2 minus 9 divided by 8. I'm getting negative 10, negative 81 over 8. So I get negative 81 over 8. All right, then you need to find the value of x that occurs with the minimum value, which is xt, and xt is minus b over a. So it's minus 3 over 2. So now we can sketch the function. We just needed the minimum point. All right, so now we can sketch the graph. We know that it's a smile function because a is positive. Once a is positive, it smiles. So we can sketch a quadratic that smiles. All right. And then we can put in the minimum point. The minimum point, as we know it, this is the point when x is negative 3 over 2 and y is negative 81 over 8. Now you might wonder, so you might say, so sir, hold on there, where is the x and y axis? Just relax. Always put the minimum point first. You can sketch the x and y axis after. For example, you know this is negative 3 over 2, right? So the origin, which is at 0, would be to its right, and then negative 81 over 8, that's a negative y value, and so the origin would be somewhere up here. What am I saying? That this is, let me make it a little straighter. So this would be something like the x-axis, all right? Now negative 81 over 8, the x-axis is somewhere over here. You might wonder, how do I know that the x-axis is here? If negative 1.5 is YASO, then negative 1.5 for x-axis must look something like that. Now the only really should know is to draw the y-axis. This is negative 81 over 8. All right, and the graph cuts the y-axis at negative 9. So the y-axis would be somewhere right here. That's the y-axis, because it cuts the y-axis at negative 9. All right, negative 9. That's a sketch of it. So the two roots them there, these are the roots. This is your y-axis, this is your x-axis. Nice and easy, soft. Next question, which it look like sequence and series. It's asking us to evaluate the summation, which is evaluating the sum from 1 to 25 of 3 to the minus n. Now I know some persons will be hardworking enough, that's the term we should use, to add up all of them, put in 1, put in 2, put in 3, put in 4, but it's actually going to follow a pattern. Look at this, when you put in 1, 3 to the minus 1, plus, when you put in 2, 3 to the minus 2, plus, when you put in 3, 3 to the minus 3. You could go ahead and add up everything, you can keep on adding up and 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 keep on adding, but that would take forever, all right? Now it follows a pattern. This is what you're adding. The pattern that it follows, it looks like a geometric progression with a common ratio. To test if it's a geometric progression, then it must follow a common ratio of T2 divided by T1, which must be the same as T3 divided by T2. So check it. So work out what is 3 to the minus 2 over 3 to the minus 1. Check that. 3 to the minus 2 divided by 3 to the minus 1 divided by 3 raised to the minus 1. I get 1 over 3. 3 to the minus 2 over 3 to the minus 1, I get 1 over 3. All right? Now, of course, you're going to get the same if you put in 3 to the minus 3 over 3 to the minus 2. You're going to get the same if you put 3 to the minus 4 over 3 to the minus 3. And so that is indeed the common ratio. So what does that mean? This is a geometric series and we're evaluating the sum. What we're really evaluating is S25. Remember, for a geometric series, the summation formula is A r to the n minus 1, a times r to the n minus 1 over r minus 1. This is a summation, this is a formula for a geometric series, or some people like to use this, a times 1 minus r to the n over 1 minus r. Whichever formula you want to use, that's up to you. All right, generally you use it when it is, this one for when it's divergent and this one when it is convergent, but it doesn't matter in this case, any one of them going to give you the same answer. So you're going to plug in a, which is the first term, as 3 to the minus 1. So it's 3 to the minus 1 times r is 1 over 3, raised to the n is 25, minus 1, over 1 over r minus 1. R minus 1 is just 1 over 3 minus 1. So we're going to put this in our calculator. Put in our calculator and we're going to get, just working it out now, r is 1 over 3, and that's raised to the 25th power, and it's multiplied by a, which is 3 raised to the minus 1, and it is divided by and I getting minus a half. Negative a half, let me check that again just to make sure. 1 over 3 raised to the 25th minus 1 multiplied by 1 over 3 divided by 1 over 3 minus 1. I get a half. Actually, it's a half. So I get half. So that's the sum. So if you're brave enough, you can actually add 1 over 3 plus 1 over 9 plus 1 over 27 plus 1 over 3 to the minus 4, I think that's 1 over 81. You can keep on adding those and adding those, you're going to get a half. Nice and easy, soft. Now part C. Part C says a man invested X dollars in a company in January in 2010, on which he earns quarterly dividends, and at the end of the second and third and fourth quarter in 2011, he earned 100, 115, 130, respectively. Calculate the total dividends on the investment by the end of 2016. Okay. So each year it has 4 dividends because it says quarterly. So he started by investing X, then it's going to increase. So he started by investing, not inventing, investing. He started by investing X dollars, then it increased. So this is the first year, first quarter, then something else, then something else, then something else. That would take care of the first year. This would be 2010. All right. Then he continued now in the second year, it would increase again. All right. Then it got to 100. Then it got to 115. Then it got to 130. All right. So what do I know? What I know is that the sixth term, it follows a sequence that has a common difference of 15. So the common difference is 15. That's what I do know. And I know that the first quarter, second, third, fourth, fifth, the sixth quarter is $100 and the common difference is 15. Now the sixth term of any arithmetic progression, we can call it T6. We know that T6 is equal to A plus N minus 1 times D. All right, X is the amount that he initially invested. It's very important that we find A. All right, so what does that mean? It means that T6, which is 100, is equal to when N is 6 times D, no, 6 minus 1 is 5, so we get 100 is equal to A plus 5 times D. And we know D is 15. 5 times 15 is 5 times 15. I think that's 75, but just to make sure, yes, that's 75. So what this tells us then is that he actually started out by investing $25. All right, he started by investing $25. So $25, then he invested, then it increased by $15. So it's going to go 40 next, then 55, then 70, then 85, then bills, then 115, then 130. Cool. So now what do we need to know now? Now that we know how much he started by investing in, you want to calculate the total dividends on the investment by the end of 2016. Now, one thing I noticed, it's going to be 4 dividends in 2010. It's going to be 4 in each year. So it's going to be 4 in 2010. It's going to be 4 more in 2011. It's going to be 4 more in 2012. It's going to be 4 more in 2012, 2013, 4 more. This is 2012, 2012, 2013, 2014, 2015, then 2016. All right, so these are going to be the total amount of dividends. So it's going to be 4, 8, 12, 16, 20, 24, 28. So in total, there are going to be 28 dividends over this period or this time frame. All right, so over these years, it's going to be 28 dividends. So we need to find the sum of the first 28 terms. So first thing we need to remember is that how do we find the sum of 28 terms of an arithmetic progression? Sn is equal to n over 2 into 2a plus n minus 1 times d. That's how we find the sum of an arithmetic progression. So it's 2a plus n minus 1 times d. So what does that mean? You're going to say, sir, what that mean? All you're going to do then is just plug in n as is 28 dividends. That's what we add it up to be. So n is 28. That's what that means. So we're finding S28. So S28 is equal to 28 over 2, which is 14, times 2 times a, which is 2 times a was 25, so 2 times a is 50, plus n minus 1, which is 27, times d, and d is 15. D is 15. All right, that will give us S28. So all of this is going to work out to be 50 plus 27 times 15 multiplied by 14, that's 6,370. 6,370. That's S28. So that's the total sum on the investment by 2060. Now, we didn't have to do it this way. The alternate method, which I'm not going to write out so many, the alternate method would be to actually add up all of them. Once you find that the first, him start by investing 25, you can add up 25 plus 40 plus 55 plus 70 plus 85. Keep increase by 15 until you reach the last term. So you have to keep adding this. Keep on adding and adding and adding till you reach the last term. Keep adding 15 till you reach the 28th term, which I don't know what that would be. And then you add up all of this and you get 6,370. This one would be too long. I'm not going to write out 28 terms. So I'm just showing you the OR method to this question. Nice and easy, soft. And that takes care of question 2. And so complete section 1 of 2016. Now let's go to section 2. Now section 2 says the points M and N are the ends of a diameter of a circle. And it says determine the equation of the circle C. So the points M and N are diameters of a circle, and they want us to determine the equation of C. I love when we see a picture of what's going on. So I'm just going to draw a circle. I'm going to draw it over here, and these are two endpoints of the circle, the diameter. So maybe M is 3, 2. Maybe 3, 2 is somewhere. Let me see. X is 3, Y is 2. Let's say maybe here. This is the point M. And N is the point -1, 4. Okay, since I want to be accurate, let me make it more accurate. So M is somewhere like right here. This would be M, and this would be N. All right. So this is the diameter. All right. So to find the equation of a circle, we need the center, but the center is just the midpoint of these 2 points, right? So let's call the midpoint C. C for center of the circle. All right. So to find the midpoint, in this case, the midpoint is going to be equal to x1 plus x2. So it's x1 of 3 plus x2, which is -1, divided by 2, comma, y1 plus y2, which is 2 plus 4, divided by 2, this will give us the center. All right, now 3 minus 1 over 2 is 1. And then 2 plus 4 is 6. 6 over 2 is 3. So the center of the circle is 1, 3. Nice and easy. The center of the circle is 1, 3. Now that we have the center of the circle is 1, 3. Now that we have the center of the circle to be 1, 3, we can go ahead and continue and find the radius. The radius is going to be the distance. You can look for NC or the distance CM. Because I like working with positive numbers, I find the distance CM. That's the length of the radius R. So the radius R is equal to the distance between C and M. The distance between C and M is y2 x1 minus x2 squared. So it's going to be, C is from 1, so it's going to be 1 minus 3 squared plus, we're using the distance of the line formula, 1 minus 3 squared plus, difference in y values now, 3 minus 2, 3 minus 2 squared, and that will be equal to r squared. We don't even need to square root it, we just need to find what is r. So 1 minus 3, then you square it, that is 4, plus 3 minus 2, then you square it, this works out to be 5. So r squared is equal to 5. Now that r squared is equal to 5, the equation of the circle is x minus the center, so it's x minus 1 squared plus y minus 3 squared is equal to r squared, and r squared is equal to 5. That's the equation of the circle. Nice and very easy. Soft. All right, like when we get a diagram to see what is happening. Then it says find the equation of the tangent to the circle at the point minus 1, 6. Find the equation of the tangent to the circle at the point minus 1, 6. First, I just want to check that minus 1, 6 lie on the circle. Well, even though they're asking for the tangent at the point, find the equation of the tangent to the circle at the point minus 1, 6. I just want to point out that this is actually incorrect. Incorrect because this point P is not even on the circle. So this is what AdMath is doing. They're giving us wrong question right here. Minus 1, 6 is not a point on the circle. Minus 1, 6 is not a point on the circle. But let's just go ahead and do this question and find the equation of the tangent. But they're giving us wrong questions like this because this point is not on the circle. It cannot be on the circle. All right, and I don't like when they do that. All right, so let's say P is here, which we know it is not. All right, so you have some tangent. Let's just call it P, and we want the equation of the tangent. To find the equation of the tangent, we need to first find the normal at P, and the normal will pass through the point P and the center. All right, this will be the normal. So first we need to find the gradient of the normal. And the gradient of the normal is equal to the y value at P minus the y value at C. So it's y minus 3 over the x value at P minus 1 minus the x value at C. So that works out to be 6 minus 3, which is 3 over negative 2. So that's the gradient of the normal. If the gradient of the normal is 3 over negative 2, then the gradient of the tangent is 2 over 3. If the gradient of the tangent is 2 over 3, then we can proceed to find the equation of the normal. The equation of the normal is then y minus y1, y minus 6 is equal to the gradient of the tangent, 2 over 3 into x minus x1, which is x minus minus 1 or x plus 1. That's the equation of the tangent. You may proceed and you can go ahead and just put this in its standard form, but I won't because that's a waste of time. This will be the equation of the tangent. Nice and easy. Now, the vectors part of the question. It says the position vector of 2 points A and B relative to a fixed origin O are A hat and B hat respectively, where A hat, this symbol above it means A hat is a 1, 2, and B hat is minus 3, 5. Lies on AB such that PB is a quarter AB. And then they say find the coordinates of OP. All right, so this is just CSEC maths question. We know what is vector PB. Vector PB, as we know it, is equal to vector of the last, which is OB, minus vector of the first. So this is OB minus OA. All right, that's vector PB, but it's also equal to a quarter vector AB. So it's equal to a quarter of vector AB is really OB minus OA. That's vector AB. All right. So pretty much we have this equation we're solving. Vector OB, and my apologies for writing OA here. This should be OP. It should be OP. So we have OB minus OP. And that's equal to a quarter OB minus a quarter OA. And all we're going to do is make OP the subject. So we have a quarter OB minus a quarter OA. Nice and easy, soft. So let's go ahead and make OP the subject. To make OP the subject, minus is here. So let's make OP the subject by bringing OP over here and bringing everything else over there. So what we're going to get is OB, and I'm going to bring over a quarter OB over here to get minus a quarter OB. Then I'm going to bring over the minus a quarter OA over here to get plus a quarter OA. And that's equal to vector OP. All right, so I bring over the OP over here to say that's equal to vector OP. So now that I have what vector OP is, I can just add them now because I know what OB is. OB is negative 3, 5 minus a quarter of negative 3, 5 plus a quarter OA, which is a quarter of 1, 2. And that will give me vector OP. All right. This will give me vector OP. But it said find the coordinates of OP. So I can't stop here. So I have to actually work it out. So let's simplify it. So, okay, let me see. Simplifying this. The x coordinate is just going to be minus 3. Minus a quarter times minus 3 is plus 3/4. Then a quarter times 1 is plus a quarter. Then I have 5 right here. Now minus a quarter times 5 is minus 5/4. Then I have a quarter times 2. A quarter times 2 is a half. Nice and easy. So now we can continue. So now you have minus 3 plus 3/4 plus a quarter, minus 3 plus 3/4 plus a quarter. That's negative 2. This is negative 2. Then you have 5 minus 5/4 plus a half. What are you getting? 5 minus 5/4 plus a half. I'm getting 4.25. I want to write 4.25 as 17/4. So it's minus 2, 17/4. All right. So that is vector OP. Nice and easy. All right. So if we wanted to actually just write it, and maybe you want to put it in numbers. I don't know. Some persons like to see numbers. Instead, when I say numbers, I mean decimal numbers. So you can write it as 4.25. Depending on what flavor you are, you write it how you want. That's vector OP. Question 4. Question 4 says, the following diagram, not drawn to scale, shows the area of sectors AOB and DOC, and it says OB and OC are X and X plus 2 respectively. And it says if theta is 2 pi by 9, calculate the area shaded. All right. I really don't like this question because they don't even have a connecting part that is going to end up somehow making us find X. So I really don't like this question, but let's just do it anyways. The area shaded, AS for area shaded, it's equal to area of the sector, DOC minus the area of the sector AOB. Now area of a sector is equal to a half r squared theta. All right, so that's the area of sector, half r squared theta. So it's a area of the sector is a half r squared, which is x plus 2 square theta, and they have this, and theta is of course 2 pi by 9. So it's a half r squared theta minus a half r squared theta. So it's minus a half. In this case, r is x. It's a half x squared 2 pi by 9. Now, maybe you want to simplify this. It's up to you. If you want to simplify it, you can notice that this 2 is going to cancel this 2. All right. And this 2 cancels this 2. So if you want to simplify it, you can get that it is equal to pi over 9 into x plus 2 all square minus x squared. X plus 2 all square minus x squared. Now you may want to simplify this if you want, right? You can simplify this if you want. You can identify that this is a difference of 2 square and then simplify it, or you can expand out the bracket and simplify it. Let's simplify it then. Due to shortage of space, I'll expand the bracket inside here. So it has to be x plus 2 all square, as you know it is x plus 2 all square. We know that this is x squared plus 4x plus 4. But then the x squared over here going to cancel the x squared over here. And so you just going left back with pi by 4 times 4x plus 4. That's all we're going left back with. Nice and easy. Soft. So that's the area. And remember, area is in terms of centimeters squared. Nice. Now let's look at the next part, part B. Part B says, given that cos of 30 is root 3 over 2 and the sine of 45 is root 2 over 2, evaluate the cosine of 105 degrees. Now, they give us 30 and they give us 45, but they don't give us the important one, which is 60. You see what I'm saying? The one that I'm going to use is the cos of 60 plus 45. That's 105, don't it? I can rewrite the cos of 105 as cos 60 plus 45. Why would I need 30? I don't need 30. I need 60. Why didn't they give me what cos 60 is? Cos 105 is cos 60 plus 45. Now cos 60 plus 45, that's going to be equal to the cos of 60 times the cos of, let me write it in a new line. It probably won't fit right here. So cos 60 plus cos 45 is equal to the cos of 60 times the cos of 45. So it's equal to the cos of 60 times the cos of 45 minus the sine of 60 times the sine of 45. That's how you evaluate this question. So then what is cos 60? Cos 60 is a half, and cos 45 is root 2 over 2. So this is going to work out to be a half times root 2 over 2 minus the sine of 60 is root of 3 divided by 2. And then the sine of 45 is given right there. The sine of 45 is root 2 over 2. So working this out, it finally works out to be 1 times root 2 is root 2. So it works out to be root 2 minus, now root 3 times root 2 is root 6. So it works out to be root 2 minus root 2 minus root 6 over 2 times 2 is 4. So let's put over 4. So it's root 2 minus root 6 over 4. Joining them as one fraction. Nice and easy. Soft. All right. 5 marks to do that, to do nothing. Now it says now prove this identity that the sine of theta plus alpha over the cos of theta. Cos of theta cos alpha is the tan of theta plus the tan of alpha. Now I always like to start with my left hand side. I love by saying LHS, my left hand side, which is the sine of theta plus alpha. And that is of course being divided by the cosine of theta times the cosine of alpha. So let's work out this easy question. The cosine of theta times the cosine of alpha. So first thing to do this question, we expand the numerator. So it is expand, now sine A plus B is equal to, the compound angle for this is sine A, sine theta, cos B, cos alpha, minus cos A which is cos theta, sine B, which is sine alpha. And all of this is being divided by the cos of theta times the cos of alpha. Nice and easy. It's being divided by the cos of theta times the cosine of alpha. Now, when we get to this question now, all we need to do now is, okay, this is now equal to, we can do the division. So let's do the division. Now we can separate them. We can separate them, all right, as sine theta cos alpha, separating them as sine theta cos alpha over cos theta cos alpha. All I'm doing is separating it into two separate fractions. All right, just separating it into two separate fractions. So this part as one fraction minus this part as another fraction. Why is this minus? This should be plus. All right, sine of A plus B, this should be plus. This should be plus. Cosine of theta times the sine of alpha over cos theta cos alpha. Cos theta cos alpha. Now that we have this now, all you're required to do now is cancel. All right, now cos alpha cancels cos alpha here. Sine over cos theta is tan theta. So that is how they get the first tan theta. Look how that easy, man. Nice and easy. Then the cos theta over cos theta cancel. And sine alpha over cos alpha is tan alpha. So we get tan theta plus tan alpha, which is equivalent to our right-hand side. Nice and easy, soft. Nice. So see it there? We're nice now. We're nice. Nice. I'll go around here, question 5. Now, when we get to question 5, we really start section 3. And section 3 now it asks us, find dy by dx given that y is the square root of 5x squared minus 4 and simplify your answer. All right. Now, to do this differentiation, you have to rewrite it as 5x squared minus 4, and you have to raise it to the half power. All right, so you can use chain rule or composite rule, whichever word you want to call it. Now you can find dy by dx by saying dy by dx is equal to carry down the power. So you bring down the half, subtract 1 from the power. So you write 5x squared minus 4. And you raise it to the minus half. And then you multiply it by the differential inside the bracket. The derivative of 5x squared is 10x. And that's that. So now you can actually find what is dy by dx. dy by dx is equal to, now, a half of this times 10x. Well, a half times 10x is 5x. And then right here, 5x squared minus 4 to the negative half. That can go in the denominator as the square root of 5x squared minus 4. So that is dy by dx. dy by dx is 5x over the square root of 5x squared minus 4. Nice and easy, soft. The next part of the question says the point P, which is 1,8, lies on the curve with the equation 2x times x plus 1 all squared. And it says determine the equation of the normal to the curve at the point P. So The point P, which is 1/8, lies on the curve with equation this. Determine the equation of the normal to the curve at P. So first thing, to find the equation of the normal, we need to find dy by dx. Now dy by dx is going to be equal to this curve right here. To find dy by dx, I'm going to have to use product rule. Keep the first times the derivative of the second, and the derivative of the second is 2 times x plus 1. Keep the first, then differentiate the second, plus keep the second and differentiate the first. Differentiating the first, I get 2 times x plus 1 all squared. All right, so that's dy by dx. Now I need the gradient when at P. All right, now the gradient at P is going to give me the gradient of the tangent at P. So at P, we know that x is equal to 1. At P, the gradient of the tangent is going to be equal to, I plug in x as 1 to get 2 times, when x is 1, this becomes 2 times, x is 1, I get 1 plus 1 is 2, 2 times 2 is 4, so I get 2 times 4, plus 1 plus 1 is 2, 2 squared is 4, 4 times 2 is 8. So this works out to be 2 times 4, 8, plus 8, which is 16. All right, so that's 16. So that's the gradient of the tangent. If the gradient of the tangent is 16, then that is telling me that the gradient of the normal is going to be negative 1 over 16. So that's now the gradient of the normal. So then what's the equation of the normal? The equation of the normal at P is then y minus the y value at P, which is y minus 8. That's equal to the gradient of the normal, which is minus 1 over 16, times x minus the x value at P, which is x minus 1. That's the equation of the normal at P. Nice and easy. Now this part of the question says, obtain the equation for each of the 2 tangents drawn to the curve at the points where y is equal to 16. What? Obtain the equation of each of the 2, obtain the equation of each of the 2 tangents drawn to the curve y equal x squared at the points where y is 16. Okay, I understand now. So, didn't like the wording at first, but if you think about the curve y equal x squared, I'm just going to give you a rough sketch. If you think about the curve y equal x squared, it looks something like this. This is x and y axis. This is it. All right, this is the x-axis is the line y equals 0. All right, this is y equal x squared. When y is 16, y is 16. When y is 16, where is 16? This is the line y equals 0. So y equals 16 is, the line y equals 16 is somewhere here. I'm just showing you, this is a rough sketch. This is the line where y equals 16. They want the 2 tangents. The 2 tangents is for the curve. So this is 1 point on the curve. When y is 16, then x is going to be 4. This is when x is 4. And when y is 16, x is also negative 4. So what they're asking us to find, so this is just graphically, what they're asking us to find is the equation of this line, that's a tangent at that point, and the equation of this line, which is another tangent at this point. So that's what they're asking us to do to find these 2 equations. So it says obtain equation for each of the 2 tangents to the curve where y is 16. So they're asking us to find the equation of these two black lines. So come, let us do that. It says obtain each of them. So first thing, you can tell them that when y is equal to 16, you're gonna get that x is equal to plus or minus 4. Clearly. And so if y is equal to x squared, and let's find dy by dx, then dy by dx is going to be equal to 2x. That's dy by dx. dy by dx is 2x. All right, so let's find the equation of the first tangent. So I'm going to call it first tangent. All right, so first tangent means t. Now, first thing I need is a gradient of the first tangent, so I'm going to call it m1. The gradient is when x is -4, the gradient is -8. So the equation of the first tangent is going to be y minus the y value of 16, and that's equal to the gradient of the tangent, -8 times x minus x1. x1 in this case is x minus -4, so it's x minus -4 is x plus 4. So that's the first tangent. Now I'm going to write second tangent. Second t means the equation of the second tangent. The equation of the second tangent is going to be y minus 16 is equal to the gradient of the second tangent, which is +8. How do I know it is +8? When x is 4, he's going to give us the next gradient. When x is 4, 2 times 4 is 8. 2 times 4 is 8. And so the equation of this is now y minus 16 into x minus 4. Nice and easy. So as you can see, this is the equation of the first tangent. This is the first one. This is the equation of the first tangent. That's for this black line right here. And this one is for the equation of the second tangent, which is this black line right here. All right, you can go ahead and put it in standard form, but it did not ask me to do that. So I am finished right there. Soft. This takes care of question 5. Question 6. Question 6 want me to work out the indefinite integral of 3 cos theta minus 5 sin theta d theta. And so to work out this integral of 3 cos theta minus 5 sin theta d theta, to work this out, we're going to get the integral of 3 cos theta minus 5 sin theta. When I integrate cos, let me not put by the integration sign, I'm just going to do it. When you integrate cos, you get sine. So this becomes 3 sin theta. Then when you integrate sine, you get minus cos. So you get minus become plus. So you get 3 sin theta plus 5 cos theta. But then when you integrate, you add a constant of integration. So you put plus k. Imagine they give you 3 marks for that. Nice and easy. Soft. Let's go ahead and continue. So now we're here, we're evaluating the integral from 1 to 3 of 2 over x squared minus 3 plus 2 x cubed dx. So let's do this integration. So if we're integrating this now, right? We're doing this integration. The integration of this is going to be equal to, first thing I want to rewrite this. Don't look at it as 2 over x squared, please. I want you to look at 2 over x squared as 2x to the -2. So when you're integrating it, you can know that when you integrate that, it becomes 2x to the minus 1, add 1 to the power, and divide by the power, minus, add 1 to the power, so it becomes 3x, plus 2x cubed, you add 1 to the power to get 2x to the 4, divide by the power of 4. And you're integrating this from 1 to 3. So what does that give us? That's equal to, plug in when x is 3. Plug in when x is 3 first, you're going to get, when x is 3, we're getting 2 times minus 2 over x is 3 minus 2 over 3 minus 3 times 3 is 9 plus, plug in 3 here, 2 over 4 is really a half, so it's really a half of 3 to the 4th power. So that's what you get when you plug in 3, and then you're going to subtract when you plug in 1. When you plug in 1, you're getting 1 to the minus 1 is 1, 2 over minus 1, that's minus 2. Plug in 1, you get minus 3. Plug in 1, you get plus a half. So now we'll put all of this in our calculator and see what we get. So let's work out this part first. Minus 2 over 3 minus 9 plus a half of 3 raised to the 4th power. And I am getting 30.83. I generally don't like to write decimals, but in this case it seems easier. 30 and 5 over 6 minus negative 2 minus 3 plus a half. That's minus 4.5. So it's minus negative 4.5, so it becomes plus 4.5. So what we get is, the integral of that works out to be 30 and 5 over 6 plus 4.5. I get 35 and 1 over 3. I get 106 over 3. Nice and easy. Soft. All right, let's look at part B. Part B says the following figure shows a finite region on the curve, and the curve is y is equal to x minus 2 all squared plus 5. So they give us a curve and they complete the square. What I'm going to do is I'm going to expand out this. I'm going to put it in regular form, in standard quadratic form. This would be x squared minus 4x plus 4 plus 5. And you might ask me, so sir, why did you do that? If I put the curve in regular quadratic form, or what's known as standard quadratic form, it makes it easier for me to integrate. So y is equal to x squared minus 4x plus 9. This looks easier to integrate. Now, let's say we want the area under the curve. The area under the curve is going to be equal to the integral from 1 to 2. So integrating from 1 to 2 of the curve, which is x squared minus 4x plus 9. That's what we're doing, x squared minus 4x plus 9. Nice and easy, soft. So this is what we're doing. We're finding this area. So when we integrate this, what do? We add 1 to the power, get x cubed, divide by the power, minus 4x add 1 to the power to get 4x squared, divide by the power of 2 plus 9x. And we're integrating from 1 to 2. Integrating from 1 to 2. So let's go ahead and knock ourselves out. Let's go ahead and knock ourselves out with this nice question. Plug in 2 first. Plugging in 2, we get 2 cubed, which is 8, which is 8 over 3, minus, plugging in 2, we get 2 squared, which is 4. 4 times 4 is 16. 16 over 2 is 8. So that's minus 8, plus 2 times 9 is 18. And then we subtract, plugging in 1. When you plug in 1, you're going to get 1 cubed over 3, which is 1 over 3, minus plugging in 1, minus 4 over 2, which is 2, plus plugging in 1, we get 9 times 1, which is 9. So what does that work out to be? That works out to be 8 over 3 minus 8 plus 18. That's 12 and 2 over 3. Minus, we work out this side now, which is 1 over 3 minus 2 plus 9. That's 7 and 1/3. So we get minus 7 and 1 over 3. When you work this out, 12 and 2 over 3 minus 7 and 1 over 3. That's 5 and 1 over 3. And I like to write in improper fraction, so I'm going to leave it as 16 over 3. And that's units square. That's the area, 16 over 3 units square. Nice and easy, soft. Part C, and then we'll finish section 3. It says the point P lies on the curve, which has a gradient dy by dx, which is equal to 3x squared minus 6x. And it says find the equation of the curve. So dy by dx is 3x squared minus 6x. So if you want to find the equation of the curve, y is going to be equal to the integral of dy by dx. And so y is the integral of 3x squared minus 6x. All right, that's how you do it. 3x squared minus 6x dx. Now when we integrate, what we're going to get is add 1 to the power, divide by the power. So we get 3x cubed over 3 minus 6x squared, add 1 to the power 2 over 2. When you integrate, you always put plus a constant k. So that's the equation of the curve y. Now we need to find this constant k, but we know when y is 2, x is 1. So when y is 2, x is 1. So 2 is equal to 1 cubed. And you wonder why I didn't put 3, because this 3 cancels this 3, and this 2 goes into itself 1 time. 2 into 6 goes 3 times. So what we end up getting is putting in 1 cubed minus 1 square. 1 square is 1, so it's 1 cubed minus 1 plus k. Now 1 cubed minus 1 is 0, and so k equal 2. If k is equal to 2, then the curve is actually y is equal to x cubed minus 6x plus 2. Nice and easy. And you can check it when x is 1 in this. 1 cubed minus 6 times. Where get 6 from? x cubed minus 3x squared. Minus 3x squared. I can check it when x is 1 cubed minus 3 times 1 squared plus 2. Oh, see there, I made an error right here. It shouldn't be plus 2 then. Some error was made. Let's spot that. 3 times 1 is not 1. 3 times 1 is 3. And so we have 1 cubed minus 3. 1 cubed minus 3, which is 1 minus 3. And 1 minus 3 is negative 2. Then we can carry over the negative 2 to get plus 4. The k is plus 4. All right, so y is equal to x cubed minus 3x squared plus 4. All right, that is it. Nice and easy. Soft. Yep, nice and easy. All right. Just want to check it to make sure it's right. 1 cubed minus 3 times 1 squared plus 4, that's 2. So this is the curve. All right, a nice cubic equation. Now we go to the best module of the paper, which is statistics. Hola mamma mia, statistics, the best thing on the paper. So it said that use the data set provided below to answer the questions. They give us this data set, and luckily they put it in order for us, so we don't have to rearrange it. They put it from lowest to highest. Construct a stem and leaf. So to construct a stem, you're gonna create 2 columns. Over here, so is a stem. This column is a leaf. So you can write that for them. This is your stem. And over here, so is your leaf, a stem and leaf. And then looking at it, it goes from 10 to 75. So what we can put is 1, 2, 3, 4, 5, 6, 7. All right. Now, how many of them? So let's go with this one now. We realize that you have, let me want to space this a little better. So how much go with the one? You have 15, you have something with 16, 18, 18. Then now with twos, you have 20, 21, 22, 22, 22, 25, 28. All right, we don't even know what this data represents, but we just plot in the stem and leaf. Then now with threes, we have 30, 30, 32, 35. That's it. With 4, we have 40, 41. That's it. With 50, we have 52, 54, 59. Here, so we have 60, 65, 68, and we have 75. That round it out. Make sure we have all the data. This is 1, 2, 3, 4, 5, 6, 7, 8. It should be 24 data points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. So the stem and leaf is correct. Then you can just give them a key. Always give them a key. So don't tell them our key is tell them so this represents 10. All right. I don't even know what the data set is, so I just have to call it 10. 1, 0 represents 10. All right. So that's the key. Maybe if you want, you could tell them that something like 1,5 represents 15. All right. Okay. So give them the key. It says state an advantage of using stem and leaf to represent the given data. So stem and leaf, it is well organized, and so we are able to find mean, we are able to find median and mode very easily. That's the advantage of it, all right? Because the stem and leaf diagram, it is easy to find the measures of central tendencies known as mean, median, and mode. So it says determine the mode. We'll look at it and see which one occurred the most. You see 2, 2, 2, yeah, so you see a lot of 22, right? So 22 is the mode. So the mode is 22. They want us to determine the median. The median is the score in the dead middle. The median would occur at a half of the 25th position, which is 12.5. 12.5 is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the median is 30. Median is 30. We don't even need to work it out. Median is 30. Then it says to determine the interquartile range. So the interquartile range, we need to find the lower quartile and the upper quartile. All right. Now the lower quartile, so if we're separating the data in half, all right, so the first 12 stops here, and the next 12 go here. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Looking at this first half, determine the middle is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Determine the middle is between the 6th and the 7th term. All right, that's how we find the term in the middle, or some people would say a quarter of 25. And so the term in the middle is between 6 and 7, which is 1, 2, 3, 4, 5, 6, 7. So it's in between here. In between here and here is 21.5. So the lower quartile is 21.5. So the lower quartile is equal to 21.5. How did I know that? The lower quartile is in between here and here. In between here and here. Let's find the upper quartile now. So to find the upper quartile, it's going to be 3/4 of 25, which is the 18th and 3/4 term. So really and truly it's between the 18th and the 19th term. This is 13, 14, 15, 16, 17, 18. So between the 18th and the 19th term is these two. And so the upper quartile, that looks like 50. Is that 53? Yes, 53. So the upper quartile is equal to 53. So now we can find the interquartile range. I like to call it IQR. IQR, interquartile range, is the upper quartile 53 minus the lower quartile. And the lower quartile we found was 21.5. We do their differences. 53 minus 21.5, 31.5. Nice and easy. Soft. And that's it. 53 minus 21.5, that's 31.5. Nice and easy. Softy, softy, soft. Now part B. Part B says that two events A and B are such that the probability of A is 0.5, the probability of B is 0.8, the probability of A union B is 0.9, and it says calculate what is the probability of A intersect B. Now there's just a simple formula to do this. The probability of A intersect B is equal to the probability of A plus the probability of B minus their union. The probability of A plus the probability of B minus their union minus the probability of A union B. That will give us the intersection. So that's a simple formula to remember. So let's apply that formula right here. So we're going to get the probability of A intersect B. That's going to be equal to the probability of A, 0.5, plus the probability of B, 0.8, minus their intersection of 0.9. Not their intersection, their union. So we have 0.5 plus 0.8 minus 0.9. So 0.5 plus 0.8 minus 0.9 is 0.4. So that's the probability of A intersect B, 0.4. Now they want the probability of A given B. The probability of A given B, is actually equal to the probability of A intersect B over the probability of B. That's conditional probability. Now that's equal to probability of A intersect B, which is 0.4, over the probability of B of 0.8. 0.4 over 0.8 is a half, known as 0.5. That's the probability of A given B. It's a state given reason if A and B are independent, yes or no. They are independent if the probability of A times the probability of B is equal to the probability of A intersect B. So let's work it out. The probability of A times the probability of B is equal to the probability of A is 0.5 times the probability of B of 0.8. That's equal to 0.5 times 0.8. That's equal to 0.4. Also, the probability of A intersect B is equal to 0.4. And so yes, A and B are independent events. Nice and easy. They are independent events since the probability of A intersect B is equal to the probability of A times the probability of B. That's why they're independent. Nice and easy. Soft. All right, final part of this easy statistics question. They say a bag contains 3 red balls, 4 black balls, and 3 yellow balls. 3 balls are drawn at random. Find the probability that the balls drawn are all the same color. So the probability of all the same color is, so the probability of getting same color. Why didn't I start the question up there? Yeah, I don't know why I like to write. I don't like these small lines, so I'm going to write down here. Probability of being the same color is equal to the probability that you draw 3 red balls, or it can be you draw 3 black balls, or it can be that you draw, where you can draw 3 black balls, or you can draw 3 yellow balls. All right, that's the probability you draw the same color. Nice and easy. So let's look at how realistic this is now, which is the probability. The probability of drawing red, red, red. So to get red, then red, then red, you have 3 red. So the probability of getting the first red is 3 out of 10. But then after you take out a red, you're left back with 9 balls. So it's times 2 out of 9 to get the second red, times the probability of getting the last red is 1 over 8. Plus the probability of getting black, 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 it's 4 out of 10 to get your first black, times, if you take out 1 black, you're left back with 3 black out of 9 balls, times, if you take out another black, you're left back with 2 blacks out of 8 balls, plus the probability of yellow, yellow, yellow. Now you started out again with 10 balls in the bag, and so 4 yellows in there, so the chance of getting a yellow is 4 out of 10. Now given that you take out a yellow, there's 3 yellow left in the bag, and there was 9 balls, so it's 3 out of 9. Times, when you take out this yellow, you only get left back with 8 yellow balls. All right. Wait, it wasn't 4 yellow, it started with 3 yellow. My apologies, so this should be 3. It didn't start with 4 yellow, it should be 3. Started with 3 yellow. Then you take out a yellow, this would be 2 yellow. And this would be 1 out of 8. So we work that out. That would be the probability of getting the same color. So 3 over 10 times 2 over 9 times 1 over 8 plus 4 over 10 times 3 over 9 times 2 over 8 plus 3 over 10 times 2 over 9 times 1 over 8. That works out to be 1 over 20. 1 over 20. So that is a chance of getting the same color. So there's a 5% chance you'll get the same color. Very unlikely. So the chance of getting the same color is very, very slim. There is a 5% chance realistically of getting 3 same colors. Full stop. I know I wouldn't. All right, just to add some fun to it, you're telling them that I definitely wouldn't put my hand in the bag and take out 3 red or 3 black or 3 yellow, a matter of fact. I just wouldn't. I'm just not that lucky. All right, so have a sense of humor and tell them that. Nice and easy. Question 8. Question 8 goes now to say a motorist starts from a point X and travels 100 meters due north to a point Y. So the motorist travels 100 meters to a point Y at a constant speed of 5 meters per second. He stays at Y for 40 seconds, then travels with a constant speed of 10 meters per second to Z. On this following grid, draw a displacement time graph. Now, very good question. Why do I say that? It tells me that him travel 100 meters, traveling at 5 meters per second. Now, speed is equal to distance over time, all right? And they don't give us the time. So if you switch it, you get that the time is equal to distance over speed. Distance over speed. So that means 100 divided by the speed, which was 5, is 20 seconds. So that means him take 20 seconds to travel the first 100 meter. All right, so this here says a S, and this here says a 5. And no, there's no distinct difference, but this is S, this is 5. So it takes 20 seconds for him to travel the first 100 meter. Then it takes him 40 seconds to stay at Y. Then he travels at a constant speed at 10 meter per second for 200 meter. So again, we need to work out the time for the last part of his journey. And the last part of his journey, the time is going to be equal to the distance of 200 over the speed of 10. 200 over 10 is 20. So 20 and 20 is 40, and 40 is 80. So the total time he's been traveling for is 80. So look how we're going to break it up. 10, 20, 30, 40, 50, 60, 70, 80. So it says that at first, he starts at the point X, starts at X, can call that point X. And he travels 100 meters from X at a constant speed of 5. So this is 20. All right, how I want to draw 100. Well, how I want to scale it, because 10 and 200 and 100 is 300. Let me see how I can scale it. All right, how do I scale it? Let's say 25. No, I don't want to scale it like that. I want to get the scaling absolutely spot on. 20, 40, 60, 80, 100. Let's say here is 100. I'm going to go with here is 100. This is 100 meter. All right, I just want to get the scaling right. So the first 20 seconds, he travel 100 meters. So this is this now. After him travel this 100 meter in 20 seconds, he gets to his destination Y. So this is his destination Y. And it said him go and chill at Y for 40 seconds. So while he's at Y, he might travel for 20 seconds. After traveling for 20 seconds, he need to stop. Oh gosh, he's unfit. So 20, 30, 40, 50, 60. 60 is here, so. He stays at Y for 40 seconds, all right? So he's still at Y now, just stay at Y for 40 seconds. Then it says, he then travels at a constant speed of 10 meters per second, 200 meters due south. Now, if going up is north, then going down is south. So going down would mean that he's going down. This is 100. This is minus 20, minus this, minus. Right here is 20, 40, 60, 80, 100. This is minus 100. So going from 100 to origin is 100 meter. Then going down, make another 100 meter. So he travels then to this point, to some point Z, because it says he goes south, you know, he went south. That's what south means, so he traveled down. So that's our displacement time graph. That's 5 marks. Thought it could have given 6, given that we had to do the calculations to find time. Maybe they could have given 1 more mark, but that's what they did. No problem. It says calculate the average speed of the journey. Average speed is total distance divided by total time. All right, so average speed is equal to total distance divided by total time. So the average speed, I'm going to call it V. Just going to call average speed V. The average speed V is equal to the total distance. We traveled 300 meters in total. 300 meters divided by the total time. I think it was 80 seconds. So its average speed is 300 over 80, which is 3 bills divided by 80 is 3.75. This is going to be 3.75 meter per second. That's its average speed. Now what's next that they ask? Find the average velocity. Now here's the difference now between average speed and average velocity. Average velocity is equal to total displacement over total time. That's average velocity. All right. That's how we find average velocity. Total displacement over total time. So let's go ahead and find the average velocity. Let's call it V again. V is equal to the total displacement. Now we're going back here, 100 meters in this direction. So the total displacement, you have 100 meters going up, then negative 200 meters. So it is 100. This is displacement. Displacement is 100 minus 200. So in reality, that's minus 100. All right, that's minus 100. So the displacement is minus 100 over 80. So the average velocity is minus 100 over 80 seconds, which is minus 1.25. Minus 1.25 meter per second. All right, nice and easy, soft. Now here's part B now. Part B is a particle starting from rest travels in a straight line with an acceleration A, given by A is cosine t, where t is in time, and it says find the velocity of the particle in terms of t. So we have to remember that if the acceleration is cosine t, velocity is the integral of acceleration. So the velocity is going to be the integral of the acceleration, and the acceleration is cosine t. When you integrate cosine t, you get sine t. So the velocity is actually sine t plus some constant. Now we need to find that constant. Let's call it plus c. Now, what is this constant? It said that it started from rest. So if the particle starts from rest initially, when v is 0, t is 0. All right, so clearly the constant is going to be 0. The constant is 0 because it started from rest. All right, started from rest. So c is 0, and so the velocity is equal to sine t. So let's write that down. That the velocity v is equal to sine t. 3 marks for doing nothing. We gladly accept this 3 marks. Now it says calculate the displacement of the particle in the interval from pi to 2 pi. Now the displacement, to get displacement, the displacement is the integral of the velocity. So it's the integral of the velocity Displacement S is the integral of velocity, and we're integrating from pi to 2 pi. Nice and easy. So when you integrate sine t, you have to remember when you integrate sine t, you get minus cos t. All right, minus cos t. So now we get minus cos t, and minus cos t, we're integrating from pi to 2 pi. So you plug in 2 pi first. So plugging in 2 pi, so the cosine of 2 times pi. So plugging in 2 pi, we're getting in minus 1 minus, when you plug in pi now, you're getting the cosine of pi plugging in the cosine of pi, I'm getting cosine pi is minus 1 minus minus 1 is 1. So the displacement is minus 1, which is minus 2 meters. All right, nice and easy. That's it, minus 2 meters. That's the displacement. Remember, displacement is negative. So what that means is that if you want to write it out in words, you can say that is the particle traveled 2 meters in the opposite direction from its start point. That is 2016 soft. So again, just subscribe, give this video a thumbs up, and yeah, see you soon in more videos. I hope you're having just as much fun as I am having. Nice.